All right. So this chapter we started learning a whole bunch of different types of equations we could solve. And the first one I want to do is solving equations with absolute values. So first thing is we need to know some things about absolute values. And one of the things we got to know is if we have the absolute value of 9 or the absolute value of -9. That's what those vertical bars mean. It means take the absolute value of it. And absolute value is an operation just like addition is the operation, right? If we saw 3 plus 2, we would know what we want to do is we want to combine these two together. And it's probably been a while since we thought of addition as a move like that, right? Absolute value is the same thing. Basically what it says is what's like the overall size of this thing, or another way to think about it is what's its distance from 0, right? So like what is the size of 9? Well, 9 is like 9 big. And -9, well, -9 is 9 big, right? It comes up in a lot of applications, such as distance, where it doesn't make any sense to have a negative value. You can never be like, you never go on like Google Maps and say like, oh, hey, I want to get to the coast, and then say, okay, yeah, just go like negative 50 miles in this direction, right? It's always going to give distance as a positive direction. So let's take a look at how that looks in an equation. So we could have a simple equation like this, right? Where it looks kind of deceivingly simple, huh? X plus 1 equals 4. Some of you guys are probably already thinking, okay, I know what the solution to this one is, 3, because 3 plus 1 equals 4. There will be another solution to this, though. Absolute values, I would say 90% of the time have two solutions in them. So the way to get rid of this absolute value sign is we need to split this into two equations. And when we split into two equations, the two equations we're going to get is x plus 1 equals a positive 4 and x plus 1 equals a negative 4. So think about why that is. If I cover up what's in here, right? And so you don't know what's inside this absolute value. What is going to give me an output of 4? Well, if what was underneath my hand was a positive 4, the absolute value of positive 4 is 4. That's why I have this first equation. If the output was, if I could make x plus 1 equal 4, then it would work. The other thing is, if what that was underneath my hand was a negative 4, the absolute value of negative 4 is a positive 4 as well. So if this thing, x plus 1, was equal to negative 4, I would take the absolute value of it and get 4 again. So the way to undo absolute values is we need to split into two equations. So I'm going to solve these equations like I solve every other equation I've been given. Right, where we're just going to undo the things that need undoing. And not only do I get x equals 3 as an answer, I get x equals -5. So 3 we can check easy, right? 3 plus 1 is 4, the absolute value of 4 is 4. -5, think about that. -5 plus 1 is a -4. Okay, and I take the absolute value of that, and it's positive 4. Now obviously these are going to get a little bit more complex, right? What if we had one like this? Let's do -7, why not? Okay. So now it looks more complex, but this is all window dressing, right? It's just there to kind of intimidate us, but we're not scared. Basically what I want to do is I need to take care of this 2 and I need to take care of this 5. And the question is, which one do I need to take care of first? Because I want to get my absolute value sign all by itself. So what I want to do is I want to first look at this 2. This is 2 times the absolute value. Now I can't distribute that in, and yeah, there's not much I can do here. I can't just say that this is like 2x minus 14 anymore. I can't get rid of it in any clever way, right? So I'm just going to hold on to it and just know that's 2 times that. I'm going to follow my standard order of operation rules and how I solve equations. Subtract the 5 from each side, and I get 2x minus 7 equals 6. So now the 5 is gone. Now I want to get rid of this 2. Remember, that's multiplication, so the way to get rid of multiplication is I'm going to divide both sides by 2, and that's going to cancel out. So what I have left is x minus 7 equals 3. So now when I split into two equations, I'll get x minus 7 equals a positive 3, and x minus 7 equals a negative 3. That's going to give me my two solutions. This one's going to get me, when I solve it, x equals 10. And this one's going to get me x equals 4 when I add to both sides. Now, the thing that we have to be cautious about on these is, what if we were to have something like this? The absolute value of, let's say, 2x minus 4 equals negative 10. So it looks like the same problems we were doing and we have confidence in solving, right? But when I get going on here and get the absolute value all by itself, the issue comes up that right here, right? Typically this is where it's split into two equations, but just think about it for a couple seconds. What value would I have to have underneath my fingers in between this absolute value that would give me an output of negative 6? See, absolute values make everything positive, so if it was a 6, it would spit out a 6. If it was a negative 6 underneath here, it would still spit out a positive 6. So how could it ever spot out a negative 6? It can't. When you still have the absolute values right here, and there's a negative right here, that's going to be a situation where we're going to have no solution, because there's no way I can have an absolute value give me an output of a negative.